Welcome to solverfy.
So we're doing chapter 22, problem 37 here. So it says, if an electron of mass 9.1 times 10 to the negative 31 kilograms escaped from the surface of the inner cylinder in our previous problems, which is given here. So we have two concentric cylinders with charge on them. The inner one has a charge of positive Q and the outer one has a charge of negative Q. So with negligible speed, what would its speed be when it reached the outer cylinder? Okay, so we can use the work energy theorem to calculate what the speed is. So it says the work is given as the integral of the force dotted with the change in r vector. And this is equal to the change in kinetic energy. So this is 1/2 mv final squared minus 1/2 mv initial squared. So now we can set the force equal to the electric field times the charge of the electron and insert that in, and we can see that the work is given by integrating from R1 to R2 of the force, and the force is given by Q, big Q, over 2 pi epsilon naught L R. And we integrate with respect to R, so it's dr. And so integrating this is it's just an integral of a 1 over r, which comes out to be the natural log. And so the constants out here are q over 2 pi epsilon naught L, and then we have ln of R2 over R1. Cool. So if this is our work, this equals work, and we're trying to figure out what our velocity is. So if we take the initial velocity to be 0, then we know that our velocity is given by square root of 2 work over m. So let's plug that in, and we are left with square root of q over, or let's do ln of R2 over R1. And the 2 cancels out with this 2, and we're left with m pi epsilon naught L on bottom. Awesome. So now we should be able to plug all of these in. So all of these values are given to us from problem 36. So let's plug this in. Our little q is negative 1.6 times 10 to the negative 19. Big Q is negative 0.88 times 10 to the negative 6. I'm going to go ahead and continue on down here. And then we have ln of 9 centimeters over 6.5 centimeters, all over our mass, which is 9.1 times 10 to the negative 31 kilograms, times pi, times 8.85 times 10 to the negative 12 for epsilon naught, and lastly, times L, which we said is 5 meters. This is lots of stuff, but we can just put it all in our calculator, and we get out a velocity of 1.9, oops, not 1.97, 1.9 times 10 to the 7 meters per second. Cool. That was our velocity. Let's move on to part B now. So part B asks us if a proton revolves in a circular orbit of r equaling 7 centimeters, then about the axis between the cylinders. Okay, must be its speed. So we're doing the same thing here as we did before. So in this case, we can just set the centripetal force as mv squared over r, and this is QE. So we can rearrange, so our velocity now is given as the square root of q over 2 pi epsilon naught ml. Awesome. Let's plug this in. And this is square root of 1.6 times 10 to the negative 19 for the proton charge times 0.88 times 10 to the negative 6 coulombs all over 2 pi times 8.85 times 10 to the negative 12, which epsilon naught is. And now m is 1.67 times 10 to the negative 27 kilograms times L, which is 5 meters. Cool. So we can plug all that in and we get a velocity of 5.5 times 10 to the 5 meters per second. And again, we see that the velocity doesn't depend on what radius we're at. As long as we're between the two cylinders, it's going to have this exact speed. Awesome.